let's get into our exponent. So like I said, the first thing I want to do is just practice what we did speak about on Monday, just because, like I said on Monday, exponents is one of those sections where not a lot of people like exponents, but if you plan on doing maths all the way up until matric, it's going to be with you up until matric. And even if you don't plan on doing maths up until matric, you need to know exponents in grade 8 and in grade 9. And so it's just one of those sections that often we struggle with, but there's no need to struggle with it. If we practice it and we ask questions and we do the work, we should be okay with exponents. So Monday's lesson centered around or worked with the first rule, the first law that we need to know, which is that of multiplication. So the first law, I'm just going to do it here, tells us that when we multiply with the same bases, we add the exponents. And so basically what that means is that whenever we are dealing with an expression where our bases are the same and we're multiplying, to simplify that or to multiply the 2 or 3 or 7 things that we're working with, we just add the exponents. Now just remember, when we're working with exponents, we've got 2 parts to it. We've got the bigger number, which sits at the bottom, which is the base, and we've got the small little number at the top, which is our exponent. And the exponent tells us how many times we're multiplying the base. So this x squared is saying to me that I'm multiplying the base x 2 times. So x times x. That is essentially what an exponent tells us. So if we have a look at the first example, we've got a squared times a squared. Now the first thing we check, are our bases the same? Yes, they're both a's. And so because we have the same bases, we can now go ahead and add the exponents. Now you don't have to show the addition step, but what we're doing is we're taking the 2 and the 2 and we're adding them together. And so as Nelson's put there on the chat, we've got a to the power of 4. So we have simplified that product. Just a little side note here, guys. I know exponents are a bit tricky, so for the most part, I'm going to assume that you all mean exponents when you type it on the chat. If you want to put an exponent on the chat, what you need to do is you need to say shift and then the number 6, and that will give a little hat triangle looking thing. And so here we would type a hat 4, and that actually means a to the power of 4. So that's just like a silly little thing there. If you want to type an exponent on a chat, that's how you do it.
Hey, guys, we learned something new. So I hope everyone will use it. Actually, it's a good idea. Let's all use it. It will help you in future, you know? Let's all just use that. Instead of saying A4, let's use shifts on number 6 and press number 6 because it's the one with the copy. Okay, they call it a copy. I don't know.
Yeah.
But thank you so much. Yeah, thank you so much, Teacher Sam. Let's go, my people.
Yeah, guys, and it is super helpful. It's also like, I mean, I don't know how many of you are eventually going to start typing mathematical things, but when you start using maths programs and you start typing out exponents, one of the ways to do it is to say shift 6. So it is quite a useful shortcut to know. But anyways, if we have a look at question B, we can see we've got some coefficients here. So what we need to be careful of in question B is the fact that the numbers in front need to be dealt with as well. And we know that to deal with those numbers, what we can do is we can use SNV. Now, guys, remember SNV, signs, numbers, and variables. If you do your multiplication or division in that order, you will get it right. And just a reminder, when I'm talking about numbers, I'm talking about the coefficients. So the numbers in front of your variables. So if we start with our signs, we've got a positive 2a times a positive 3a squared. Both of them are positive. That means that my answer is going to be positive. So I've got a positive answer. I've dealt with my signs. Then I go on to my numbers. My numbers are 2 times 3. We know that 2 times 3 gives me a product of 6. And so that is the coefficient for my answer. Dealt with my numbers, now I can move on to my variables. When I look at my variables, I've got a times a squared. Now, because we have the same bases, we know we can add the exponents. And we know that any variable sitting by itself with no exponent does actually have an exponent of 1. And so what that means is that I am actually adding 1 plus 2 in my exponent, giving me an exponent of 3. And so what I have here as my final simplified answer is 6a cubed. So what we need to remember is the second we start introducing coefficients, break it down, don't overcomplicate it, do it step by step. So I want you guys to try question C for me. Based on everything that we've spoken about in question A and B, I want you to give question C a try. Put your answers in the chat, and then we'll have a look. Things to remember: signs, numbers, variables, so S and V. And remember, the law says that when we have the same bases, we can add the exponents. So we can only add exponents when our bases are the same. Right, but have a look. And what I want to point out is that you've got bases of X, and you have a completely separate situation with bases of Y. So they are separate. There are two different bases. We need to deal with them separately. So just bear that in mind. Remember, guys, signs, numbers, variables. Remember that. Hopefully, we can get our products and our quotients correct. Well done, those of you using the shift 6. Very nice. Another minute or so. Okay, grade 8. Does anyone want to raise their hand to explain how they do this, or how they did this question rather?
Let's go, my people. We can do this. And thank you so much for those of you who are practicing the shifts to do the Kathy. You're amazing. I can see you. Whoa, Nelson is there. It's a volunteer.
Okay, Nelson, tell us, how do we do this? There should be a pop-up to unmute yourself. Oh, no.
I'm starting to even wonder if it's just network. You see, it's taking long. There we go. He's up now.
Nelson, you there?
Nelson, we love you, but you know, we can definitely get back to you next time. Okay, but you can put your answer also on the chat.
Yeah, I did see Nelson put his answer on the chat. Well done. It was very nice. Tandawake, do you want to try this one?
Yes, ma'am.
Okay,
How I got to the answer, ma'am? Okay, ma'am. How I got to the answer, ma'am? I said negative 2x times 3x. It gave me negative 6.
Mm-hmm.
And then also, and then for the y, I said 2 plus 1, it gave me 3y. And then I said 3 plus 1, it gave me 4y.
Okay, cool. What happened to the x's? Sorry, I don't know if I missed that.
Yes, ma'am. It's negative 6x.
I don't know if maybe my sound's going weird. Did you get negative 6x to the power 3?
Yes, ma'am, to the power of 3
Okay.
and 4.
Good. Sorry, I think my sound just cut out funny there. Well done.
Well
Good.
done, Tando.
All right, guys. So let's just chat about why this is the answer. We need to make sure we understand why. So if we start with signs, we've got a negative times a positive, which means our answer is negative. We then move on to our numbers, 2 times 3, which gave us 6, as Tandawaka said. And then we move on to the variables. Now we've got two groups of variables. We've got the x squared times the x, and then we've got the y times the y cubed. And this is now where he was saying we need to add the 2 and the 1 and the 1 and the 3. When I multiply with the same bases, I can add the exponents. And so that's exactly what I do. And that gave me the x cubed and the y to the power 4. And I take those two answers and I just put it next to my coefficient. Remember, we always want to try and write our answer or our letters or variables rather in alphabetical order. So I'll put the x first and then the y. That's just like a standard sort of convention that we try and follow. But because those bases were different, I had an x and a y, I needed to keep them separate. So I can't add exponents unless my bases are the same. If I've got two different bases, I deal with them separately like I did the x and the y. Alrighty, very nicely done. I saw a lot of negative 6, a lot of negative 6x cubed y to the power 4s coming through. So very well done, grade 8s. Right, but let's jump into essentially what we need to chat about today. Okay, I see there's a bit of an audio issue. Let me just do this. Oh. Alrighty, so if we have a look, or if we have a look today at what we want to look at, those are very weird words, but we're just going to move faster. Today we're looking at our second rule, and our second rule deals with division. Okay, so law 2 is our division law. And the division law tells us that when we are dividing with the same bases, we subtract the exponents. You can't spell subtract today. Okay, now that's all well and good, but we need to actually understand why we do that. So let's have a look at an example. If, for example, I had x to the power 5 divided by x to the power 2, I gave you that as your question. We know that one way to deal with exponents is to expand them. So if I wrote this as a fraction, I would have x to the power 5 divided by x squared. And I can write this out in expanded form. What I mean by that is in my numerator, I'm multiplying 5x's. And in my denominator, I'm multiplying 2x's. It means the same thing. I'm just writing it out in expanded form. Now, what I can do from here is I know, because when we did fractions, we spoke about the fact that we can simplify fractions through canceling. I know that I could cancel 1x in my numerator with 1x in my denominator. And I can cancel second x in my numerator with an x in my denominator. And that is leaving me with 3 x's in my numerator. So if I have a look, there are my 3 x's that I have left in my numerator. And so that leaves me with a simplified answer of x cubed, technically over 1, because I canceled everything out in my denominator. But we don't need to write the 1. We can just leave it as x cubed. Now, if we go back and have a look at our rule says to us that we could just subtract the exponents. So if I took that and applied this to my x to the power, and I applied that to my x to the power 5 divided by x to the power 2, my rule says I subtract. Now, when we subtract, we always subtract the numerator's exponent, numerator, minus the denominator's exponent. So it's always top minus bottom. So this would be x to the power 5 minus 2, and that gives me x to the power 3. what we can see is that we get exactly the same answer as if I expanded. There's my x to the power 3. Here's my x to the power 3. It is exactly the same answer. I'm just choosing to apply the rule. Now, the rule is helpful to us because what happens if we had very big exponents? If I had x to the power 37 divided by x to the power 15, I don't want to expand. I don't want to write out 37 x's and 15 x's. I want a quick way to do that. And that is either through English. And that is through then me applying my second law of exponents. So when we have the same bases, we can just go and subtract the exponents. And it comes from the fact that I can cross-cancel x's in my numerator or values in my numerator with the same values in my denominator. Right, so I'm going to just wait here and let you take a screenshot. If anyone has any questions, you can raise your hand. We are going to have a look at some examples. But any questions, now's the time to raise your hand.
Are we all good, my people? We look all good. Gigi, I see Gigi is like, yeah, ma'am, I'm even stretching already. Mbali also not complaining. Tandola Ake, nope, not complaining. Yonga, nothing. Readmates, are you okay? Readmates is the one writing. Readmates, do you know how to take screenshots, right? I hope you do know how to take screenshots because sometimes it's going to be like a lot and we're going to move faster, okay? Because I see Readmates is busy taking nice notes over there. Guys, teacher 7 is going to move on, okay? Because no one raised their hands, no one asked any questions on the chats. So we assume everyone is good and we are ready to go.
Okay, guys, so yeah, I'm moving on to some examples. We're going to try a couple, of course, and then I've used exactly the same example. So let's just change that because I'm always in my mind. Fine, everything's fine. Right, so examples. Let's have a look at our first one. We've got x to the power 7 divided by x to the power 4. Now, guys, I suppose the nice thing about exponents is there's often different ways to do exactly the same thing. Personally, I like to cross cancel. That is my chosen method, but you don't have to. So we're going to apply the laws that you can see, but I'll show you a couple other ways that you can do it. So this is telling me that I've got 7x has been multiplied in my numerator and 4x has been multiplied in my denominator. So according to my law, what I can do is I can take my numerator exponent and subtract the denominator exponent. So 7 minus 4. And that leaves me with x to the power 3. So just through applying my law, I've gotten my answer. Like I say, personally, I don't do it like this, but it also doesn't matter if you do it like this. I see it as I've got 7 x's in my numerator. Now, I wouldn't write out the 7 x's. I'll show you what I would do now in a second. But I've got 7 x's in my numerator, and I've got 4 x's in my denominator. And so what I see is, okay, cool. I can cancel. Oh, that's a bit aggressive. Let's try that again. I can cancel 1x with 1x, a second x with a second x, a third x with a third x, and a fourth x with a fourth x. And I can then see that that leaves me with 3 x's uncancelled. And so that leaves me with an answer of x to the power 3 over 1, which is the same thing as x to the power 3. So my answers here, exactly the same. I've just chosen to cross cancel. Now, again, I wouldn't write all of those x's out because that's time consuming and unnecessary. All I would do is I would say, okay, I've got 7 x's in my numerator, 4 in my denominator. I can go ahead and cancel all 4 in my denominator with 4 in my numerator, leaving me with 3. And so that is where I'm getting my x to the power 3 from. Now, any of these methods are fine. All of them are perfectly acceptable. All of them are mathematically correct. So whatever makes sense to you, I would do. I wouldn't recommend the middle one because it means you have to write out the x's and that takes up time and we don't want to take up time unnecessarily. But if you are happy to subtract your exponents according to the law, that is what you do. All right, so I will come back to this, but let's have a look at question B. I'll come back and make it smaller so you can take a screenshot. So if we have a look at question B, we've got 2x to the power 5, y to the power 3, divided by x squared y. Now again, grade 8s, this is where we use SNV, signs, numbers, variables. Positive divided by a positive is a positive, so I've dealt with my signs. When it comes to the numbers, what I need to remember is that I do actually have a coefficient of 1 in front of my x squared y. And so when it comes to the numbers, what I'm actually dealing with is 2 divided by 1. But 2 divided by 1 is just 2. That doesn't change anything. So my numbers actually stay exactly as they are. 2, and if you want to say over 1, that's fine. Now I come to the variables, and what I need to be careful of is that I've got 2 different sets of variables. I've got the x's that I need to deal with, and I have got the y's that I need to deal with. And I need to deal with them separately because those bases are different. So if I start with my x's, I've got an x to the power 5 divided by x to the power 2. So I know according to my law, I can subtract those 2, and it's always top minus bottom, leaving me with an x to the power 3. And then I've got my y's. The y's, I've got y to the power 3 divided by y. That has an exponent of 1. And so I subtract my exponents. Top minus bottom, leaving me with y squared. Now, an important thing that we need to take note of is I am writing all of my answers for the variables in the numerator. There is a reason for that. So as a little reminder for us, oh, that's again a bit aggressive. Let's try that again. We write down the answers to the subtraction. So when I say to the subtraction, excuse my fingers, I'm talking about that with the variables, where the biggest exponent was. So if you have a look at your original question, the biggest exponent of x was in your numerator. So I wrote down my answer in my numerator. The biggest exponent for y was also in the numerator. And so I wrote down my answer to the subtraction in the numerator. Wherever the biggest exponent was, that's where my leftovers go, because it makes sense. If I've got more x's at the top than at the bottom, my leftovers will be at the top. If I had more x's at the bottom, my leftovers would be at the bottom. So we just need to take careful note of where do I have more x's or more y's or more a's or whatever, and that is where our answer goes. So if we now have a look at this answer for B, we've got 2x cubed y squared all over 1. But because it's all a denominator or it's all over 1, we don't need to write the over 1. You can if you want to, you're not going to be marked wrong, but we can just leave it as 2x cubed y squared. Right, so guys, SNV applies for division as well. Just because it applies for multiplication doesn't mean we can't apply it for division. Multiplication and division go hand in hand. And what we need to remember is that we write down our answers to the exponent subtraction wherever the biggest original exponent sat. So if x's biggest exponent was originally in the numerator, that's where I write my leftovers. If it was originally in the denominator, that's where I write my leftovers. It's very important that we are putting our values or our leftovers or our answers, whatever you want to think of it as, in the correct position within the fraction. Right, so I'm going to make that a touch smaller, let you take a screenshot of A and B. We're going to take a little break. You've got a lot of information. You guys have done really nicely. While you're taking screenshots, if anyone has a question, now's the time to raise your hand. Any questions, guys? Now's the time. Good, grade 8s. Well done. I'm glad we're feeling okay about exponents. On that, if there's no questions, can I just get a thumbs up or a thumbs down in the chat how we're feeling about exponents? I'm saying you're feeling good, but that's only because no one's asking me a question. So if you're not feeling good, you need to let me know. Thumbs up, thumbs down. Rosale, thank you. Ayo, thank you. Mbali, thank you. Jacinta, thank you.
Well done, my babes. My people have this. They're like, we got this, ma'am.
Good, guys. Well done. Okay, I'm assuming we've all got our screenshots. Let us move on to our brain break. Don't worry, we're going to come back to all of those. There's your maths joke in case you want it.
Wait, I need to take a picture of the joke. Sorry, guys.
I put jokes up in my classroom, and my grade 11s, again, it seems to be my grade 11s that are quite sassy. They walked in today and they're like, "Ma'am, you had a whole holiday to put new jokes up. Where are the new jokes?" Just was like, yo, sassy. Okay, guys, so brain break. You know the deal. We wait for the correct answer on the chat. Just going to make it a bit bigger so you can see where you've got 2 bunnies versus 1 bunny, 2 porcupines or hedgehogs versus 1 hedgehog, and 2 lizards versus 1 lizard. Remember, if there's 2 of them, the value must double. So we're going to wait to see who gets the correct answer first on the chat. You're welcome to put things on the chat to help each other.
Let's go, my people. By now, we should be pros of these things. We should be pros, my people.
And remember, guys, like I said to you, this is going to help you for equations. So do give it a try because it is going to be helpful to you.
Let's go. We're nailing this. Let's go. We're nailing this. I'm loving it. Let's go, guys. Let's see who's going to arrive to the first answer. The winner of today. Let's see.
You got it, guys.
You got this. You got this.
And like I say, this is very, very helpful for equations. So it might seem like a silly, fun thing that you don't really want to do, but I promise you it's going to help you when you get or when we start doing equations. Just like the basic understanding of solving for something that you don't know. Excuse me.
Well done. That came so quick.
Oh,
OMG. Yo, who was the first? I lost. Oh, no. Nobile was the first. Yes, Nobile. Nobile was the first one. Yeah.
I missed that. Sorry, Nobile.
Me too. Well done, Nobile. Nobile is our winner. Nobile, do you want to raise your hand so you can explain to us how you got it? Well done to everyone else. I see that after Nobile, it was Masete. Oh, no. It was Kumo. After Kumo, it was Malisela. After Malisela, it was Lwazi. Then
So I
Nobile
missed so many.
again. But Nobile at the first is what Nobile said. It was him. I mean, it was her or him. Nobile, where are you? Show yourself. She puts or he puts twice the 130.
Yeah, Nobile, raise your hand. Come explain it for us. How did you get there?
Yeah, well done, Nobile. Yes, Kuma, that's right. Where's Nobile? Yeah. Are we dreaming? Nobile, I'm really coming to you. I'm gonna unmute you either way. So this is me. This is me being nauseous. Nobile, you can unmute on your side. There's a pop button. You just have to click on it. Nobile might be shy, guys. Who was the second one? Anyone who got it, please raise your hand. Nobile, I'll forgive you for now, but next time definitely I'll bug you. Because we want to understand how you got it.
Yeah.
It would be nice. So anyone who's feeling brave and got 130, please raise your hand so you can explain to us how you got there.
Yeah. We need to know how you got your answers.
Hey, guys, I know y'all got it right. Kumo, you can raise your hand also, you got it right. Moamba, raise your hand, you also got it right.
Oh,
There we
guys, I can't
go.
believe we're all shy
Oh,
all of a sudden.
did you just raise and go? Yeah, got it so fast. I wasn't expecting that answer to come so fast. Razi, raise your hand. Y'all, do you know how to raise hands? Or it's just me feeling like the vibe of raising hands, just, Caleb, raise your hand. You also got it right.
There were so many of you who got 130. I can't believe none of you can explain it for us. Otherwise, that just means we're copying answers.
Oh, now I understand why can't they raise their hand, Teacher Sam? Because someone like me, I don't know what that kukunu is. What is it called? Is it a kukunu? What is that? I know that's rabbit, but I don't know what that
A
means.
gecko? I don't know.
You see, Teacher Sam and I also don't know. So you can describe it in your own way.
Yeah,
I saw your hand being up, but now you disappeared. I don't understand why.
Hey, guys.
Guys, really, if not, then we're keeping it for the next time. We'll spend the rest of the break trying to find someone to explain to us. I am lagging, miss. Oh, okay.
Jacinta.
Gigi wants to explain. Gigi is rescuing everybody in the class. Just unmute Gigi and talk to us.
Ma'am, I say
Hello.
4 plus 18 times 7, give me 130.
Perfect. Okay, so that's on our final
Well
step.
done.
So guys, if we just, sorry, my brain. If we just have a look at where we got those values from. In the first equation, you've got 3 rabbits adding to 27, which means all of these numbers have to be the same. So all of the rabbits are 9. Now you've got a double rabbit. So that means each of these are 18. And then we have to figure out what the hedgehog porcupine thing is. Now remember, according to BODMAS, you have to times first. 18 times 18 is 324. So we need to figure out what I need to add to 324 to get to 338. And that therefore means that our little double porcupine thing is 14. So every time I see my double porcupine, I get 14. That means in equation number 3, again, I have to do BODMAS first. So 14 times 14 is 196. I need to ask myself, what do I need to add to 196 to get 204? That's 8. So 2 lizards is 8. This is why Gigi said 1 lizard is 4. The 2 rabbits we know is 18. And if 2 porcupines is 14, 1 is 7. And so now again, we do BODMAS. We need to do the 18 times 7 first. That gives me 126. And then we add the 4. And that gave me my final answer of 130. Very nice, Gigi, well done. Okay, guys, so that's solving an equation. It's finding values that you don't know. And so again, these concepts are so important when you are doing algebra and specifically equations. All right, but let's carry on with some division. Where are we? There we are. Right, so this question sort of goes back to what I said over here, where we write our answers to our subtraction where the biggest original exponent was. And this is what we're going to see in question C. Now, I don't want you to panic because we will eventually talk about negative exponents, but this is also why I don't actually use this and I use cross cancelling rather. So again, I'm going to show you two different ways. You decide how you want to do it. So if we use our law tells us to take the numerator's exponent and subtract the denominator's exponent. Now, when we get an answer of -4 in my exponent. Now, I need to be careful. We don't like negative exponents. And so I never want to leave my answer with a negative exponent. So we need to understand what this negative exponent means. This negative exponent actually means that my leftovers, I don't know how else to put that, so I'm just going to put it in inverted commas. So what we have left after we've divided are actually in the denominator. So what we actually have here is a fraction, denominator. And so this x to the power -4 actually is 1 over x to the 4. Now that might be a bit confusing. So let's take a look and see what would happen if I expanded this. That would be x times x in my numerator, and then x times x times x times x times x times x in my denominator. Now I can already see that I've got many more x's in my denominator than I do in my numerator. So it makes sense that the leftovers are at the bottom. Cancel one x with one x, a second x with a second x, and now I'm done. I've got no more x's in my numerator to cancel. And so I see that I've got 4 x's left in my denominator. Now remember, guys, you have to write your leftovers where they sit. The leftovers here are in the denominator. They need to stay in the denominator. They can't all of a sudden move. Because I canceled everything out in my numerator, I'm left with a 1. And so I do in actual fact have 1 over x to the power 4. And this is why when we get negative exponents, what we actually are working with is a fraction. We're working with leftovers that are in my denominator. Now, I prefer the method in green, the cross cancelling, just because it means that I never really have to worry about negative exponents. But with that being said, you are welcome to apply your law and subtract. Just remember, we don't like negative exponents. And what that negative exponent actually means is that the leftover for that base is in the denominator. And so we need to put it in our denominator. Yeah, I know this is a bit of a tricky concept, so we are going to practice more. But this is what you need to understand, that when your leftovers or when your exponent is negative, you have a fraction. But this also goes back to what I said, and I'm going to come back to this now. Here in question B, we write the answer to this, your English, I'm going to start again. We write the answer to the subtraction where the biggest original exponent was. My biggest original exponent was in the denominator. So my leftovers have to go into the denominator. I had more x's at the bottom, so that's where the leftovers should be. So always think about where do you have more of your base, because that is where the leftovers are going to sit. Right, before we do that question, let's just do another one like this where we have this sort of situation going on. Oh, come on. Right, so I'm just going to put a little star here. Let's say we've got 2x to the power 7 divided by 4x to the power 11. So we're having a look at this one here, 2x to the power 7 divided by 4x to the power 11. Right, so again, signs, numbers, variables, we never forget that. You need to dream about it. It needs to become part of your life. It's going to be very useful. Positive divided by positive, positive, no problem there. Then I move on to my numbers. So my numbers that I have here is 2 divided by 4. Now, if you think of this as a fraction, it's 2 over 4. That we know simplifies to a half. So my numbers here are going to simplify to 1 in my numerator and 2 in my denominator. You can cross cancel as well. 2 divides into 2 once and into 4 twice. That's why I've got 1 over 2. But now I need to deal with these variables. So if I look at my variables, I've got x to the power 7 divided by x to the power 11. If I apply my law, I will subtract 11 from 7. So x to the power 7 minus 11. And that gives me x to the power negative 4. Now remember, I don't like that negative exponent. That is an issue for me. This tells me that my leftovers are in the denominator. And so we put our x to the power 4 in our denominator. Again, this makes sense. I've got 11 x's in my denominator and 7 x's in my numerator, which means I can cancel all 7 at the top with 7 at the bottom, leaving me with 4 x's in my denominator. And so when I simplify this, I get my final simplified answer of 1 over 2x to the power 4. So whenever you are doing the subtraction and you're getting a negative answer, what you need to remember is that it actually means you have your leftovers in your denominator. And we write it with a positive exponent because we have 4 x's left. The sign of a negative just means that it needs to move into my denominator. Right, I'm going to wait in case anyone wants a screenshot. I'm also going to wait to see if anyone has any questions. Now's the time to raise your hand to ask me. Otherwise, we're going to have a look at one last example. I think we've got time for one last example. Okay. Butlale?
So, ma'am, can you hear me?
Yes.
So, ma'am, what you're basically saying is that when we have a smaller number above a bigger number, ma'am, it becomes negative.
Basically, yeah.
Yes.
Good. Well done. Well done. It's amazing how you guys can just wrap up everything I say so nicely. Well done. Kumoma, I hope I'm saying that correctly. Kumo? There should be a pop-up to unmute yourself.
Ma'am, how did we get the negative exponent?
Okay, so remember the negative exponent is coming from, like we've just said, the fact that I'm taking the small number in my numerator and I'm subtracting a bigger number. So when I'm subtracting a bigger number from a smaller number, I end up with a negative. But that negative means that it's actually in the denominator. So that's why I end up with a fraction. So the negative is coming from the fact that I've got a smaller exponent in the numerator or at the top than I do at the bottom.
Thank you, ma'am.
Okay, guys. Excuse me. Right, I want to do one more just so that we hopefully are feeling confident. Let's have a look at question D. We're going to do it together just for sake of time. So if we have a look here at question D, we've got negative 3a to the power 6b squared c over 18a squared bc. So let's do signs, numbers, variables. In terms of my signs, I've got a negative divided by a positive. We know that when we divide a negative by a positive, our answer is going to be negative. So I've sorted my signs. Now I need to go to the numbers. If I look at the numbers, and remember I'm talking about the coefficients here, I've got 3 divided by 18. I need to simplify this. So 3 can divide into 3 once and into 18 6 times. So my numbers simplify to 1 over 6. So I've sorted my numbers. Now I go to my variables. Now remember, the variables, you can only deal with the same bases. So I've got a to the power 6 divided by a to the power 2. I subtract the top from the bottom. That leaves me with a positive exponent of 4. The bigger exponent is in the numerator, so that's where I put my answer. I then move on to the b's. I've got b squared divided by b. I subtract my exponents, 2 minus 1, leaving me with b to the power 1 or just b, doesn't matter. What I need to remember, biggest exponent was in the numerator. That's where my leftover goes. So there's my b. And now when I get to the c's, what I need to remember is that they actually just cancel out. Because if I've got c divided by c, I know I end up with 1. Anything divided by itself is 1, cancels out. And so my c's actually fall away. And so my final simplified answer here is negative a to the power 4b all over 6. If you want to write the 1 there, obviously that's absolutely fine, but you don't have to. Okay, so guys, signs, numbers, variables, that is what you need to remember here.